Good morning. Welcome to the PENC Wilmington seminar. We're happy to have you with us today. My name is Katie Cox. I'm the PENC Membership Director. I've got a couple of announcements before we get started. The PENC Summer Conference is going to be in person August 29th through 31st in Wrightsville Beach. We have 14 PDHs available. We have Andrew Ritter from NC Bells is coming to talk. We've got a lot of great presentations planned, and we're so excited to see you all in person. So find out more information on our website if you would like to join us at the beach. The PENC Leadership Institute is now accepting applications for our fall 2021 class. This class is going to be virtual again, which actually makes it easy to send anyone across the state. It's a great way to support some emerging leaders in your office. Details are at penc.org, or you can email me or the class instructor, Rich St. Dennis, with any questions. And then lastly, I know we have got lots of members on the call, but also some non-members, which we love. Everyone's welcome to our events, but we do encourage you to consider membership to support the engineering profession and our programs. Membership is $2.99 a year and includes PENC and the National Society of Professional Engineers. And you can learn more on our website at penc.org. So today's Wilmington seminar focus is on coastal resiliency. Please note that you have two separate links for today's sessions. So when we finish up our first session, there will be a 15-minute break, and then join the 10:15 session using your second link. PDH forms will be emailed to you this afternoon. If you have any technical difficulties during the presentation, please use the chat box, or you can email me and I will try to assist you. We will take questions at the end of the presentation today. Our first presenter today is Angie Metlin, Vice President and Director of Strategic Funding and Regulatory Affairs for WK Dixon. Angie is a 1991 graduate of Clemson University and has been working in the water industry for nearly 30 years. She has been with WK Dixon since 2007 and now resides in Clemson. Her passion is helping her team and clients find innovative solutions for challenging problems. This often involves planning, funding, and assembling the giant jigsaw puzzles that often come along with those aspects of consulting engineering. In her role at WK Dixon, she gets to work with staff in all practice areas and across multiple states. Each day brings something new and exciting and an opportunity to learn more. Most recently, she's been working with her WKD team and clients on leveraging infrastructure resiliency into design, planning, and funding, particularly given the increase in frequency and severity of natural disasters along the East Coast. Everyone that knows Angie knows that she is one of the biggest Clemson fans around, and this passion has recently been rewarded with her being appointed to the university's Board of Visitors. Angie is the proud mom of one daughter, Holly, who is also a Clemson graduate and an engineer in the water industry and successfully adulting. That is a great accomplishment. Thank you, Angie, for being with us today, and I will turn it over to you.
Wonderful. Thank you so much, Katie. I appreciate that introduction. And I also appreciate being with you all today to talk about resilient design and how appropriate that we're here on June 10th, 10 days into the 2021 Atlantic hurricane season, when NOAA has told us that we're going to have maybe 13 to 20 named storms, 6 to 10 of those being hurricanes, so an above average season. Hope they're wrong, but we're going to be ready regardless. And that's what this is all about today. You know, we're coming out of a pandemic. Nobody saw the pandemic coming. I mean, that was furthest from our mind at the end of 2019, that we would all be sitting at home doing things for our jobs rather than going about our daily business. And we didn't see that coming. So we adapted. We became more resilient as a result of that. So we learned how to do things that allow us to react quicker and recover quicker the next time something like that happens. And the next time something maybe not quite as bad as a pandemic happens, or not quite as bad as a Category 3 hurricane taking a direct hit on our coast, but by being ready for that, we're ready to handle those challenges that happen every day in our roles with infrastructure systems. So let's get started. You know, in the intro there, we talked about the fact that events are occurring at a greater frequency and a greater severity. Rain events. It may not be a hurricane, but just normal rain events are getting more frequent and more severe. I don't care what you call it, whether you call it climate change, whether you call it sea level rise, no matter what you call it, things are happening and things are different. And we've got to adjust the way we think about those things and how we integrate that into our business, whether it be designing utility systems or operating utility systems. This resilient design thought process just needs to happen, and become an integral part of our planning. By doing that, we'll think about things in a little bit of a different way, that allows us to build in that resiliency going forward. You're never, ever, ever going to be completely prepared for every event that could possibly happen, but you can be ready for those things that are most likely to happen. And again, like I said, by doing that, you're going to be ready to meet a lot of challenges. So we're going to go on a little tour. We're going to go along the coast of the Carolinas and talk about some different projects. These kind of run the gamut, from water and wastewater projects to some stormwater projects, but just to kind of give you a flavor for the kinds of things that we're seeing and we're looking at, and some thought processes. A lot of these things aren't, I mean, they're not groundbreaking, but it's taking advantage of situations and then putting that thought and that resilient design into action. So we're going to start our tour today, in Onslow County, North Carolina. So I picked this for a couple of reasons. One, we're just going to go from top to bottom along the coast, but also because this was ground zero, if you will, for Hurricane Florence. This particular area where it was in the basically the general area where Hurricane Florence came ashore. And Onslow Water and Sewer Authority had built a new wastewater treatment plant in Richlands, North Carolina. So it's a little bit inland from Jacksonville. And the furthest thought they had in this particular location was flooding. This particular location was chosen because it did not have a history of flooding. It was outside of most of the flood zones, including the 500-year flood zone in a lot of cases. So this flooding was really not a thought process when they built this plant. Now, let me also say that this plant was only about 4 years old when Hurricane Florence hit. So it was brand new, very expensive. It was MB, still is a MBR plant. So they had debt on this plant. And the thought of losing this plant at 4 years old never even occurred to them. I'm showing this particular picture because it is a representation of kind of lets me talk through what happened, the unique situation that happened with Hurricane Florence. So the star there is where the plant is located, kind of in an area out where the New River, where the Squires Run comes into the New River, and then Cowhorn Swamp. So what happened with Florence is it came ashore, and as you remember, it kind of stalled out and it sat there. And this particular area was located in that quadrant of the storm where it was getting the most onshore push of wind and everything. So water was being backed up from the New River into this Cowhorn Swamp right here. And so much water that this plant site actually flooded to the point that the operators that had stayed there and had battened down the hatches to keep operations going through the storm had to be rescued by swift boat rescue teams in order to get them out of there because the flood waters rose so quickly, and the only part of the site that was not flooded was a little corner of the site where the administration building was, but they didn't know if that was going to be flooded as well. This is a picture that was taken from one of the security cameras. So these are the reactor basins at the plant, and what you're seeing here in the foreground are actually the control panels for some of the pumps that operate this plant, and you can't see the pumps because they're flooded. another picture here of the plant site kind of after the rain had stopped a little bit. But I show this one because, I mean, it looks like it was built in a lake. You know, it wasn't. And this is particularly of import because what I wanted you to see here is this building right there is the electrical building that controls the entire plant. And it was flooded. So every motor control was fried. The plant had no electricity. Back here behind it is the generator. It was elevated and it did not flood. As a matter of fact, it just was humming along. You know, when the electrical building was flooded, but it had nothing to power. So so that was a really big problem that Onwassa ran into with this particular event. So what happened? How did we go about looking at this particular problem and devising a solution? So of course, Onwassa said, we never want this to happen again. This is too expensive of a plant. We can't have a flood like this again. So we looked at all sorts of solutions, everything from berming this site, basically putting a berm around it, to looking at the deployable devices like flood walls and things like that to go around critical structures. But all of those came with significant challenges in and of themselves. For instance, if you berm it, you will collect stormwater in there under normal conditions, so you got to get rid of that just under rain events. For the deployable devices, that takes manpower, and generally in the face of an event like a hurricane, it's all hands on deck doing everything that all the other stuff that they've got to do in order to prepare for an emergency. So a lot of options were considered, and we took an approach because at the same time we had actually started working with, or we're getting prepared to work with Onwassa on their risk and resiliency assessment. So we took a page out of that water system risk and resiliency assessment, and we broke this down into, okay, let's say this happens again. What are the pieces of this plant that are absolutely critical that you need to have in the event that a flood similar to what happened with Florence happens again? So we identified all the critical aspects of the plant. Of course, that motor control center, the brains, the heart of that plant was primary, and we knew we had to get that up. And then we identified several other key pieces of equipment and components throughout the plant site to elevate, to flood proof, to do all of those things that allow them not only to operate easily and effectively and efficiently under normal conditions, but also give them some protection in the event that this sort of event happens again. So we're raising platforms, putting in platforms, raising control panels, protecting critical motors and pump parts with a new floodproof building, raising the electrical building as well. We're going to go ahead and raise the generator up more as well. And this particular aerial shows you where the 500-year and 100-year flood elevations are on this particular site. So we're getting them out of the 500-year flood elevation in many instances, so that gives them future protection for an even more significant event as it goes forward. So how did they fund this project? So Onwassa was very fortunate. They actually had an insurance policy, not only on their system as a whole, but on this particular site by itself. It was a $5 million policy. So a lot of that kicked in and allowed them to do a lot of the immediate repairs that needed to be done. And then also it kind of carried over into some of the mitigation. They also had on deck, they did all the steps that they needed to do to get qualified for FEMA public assistance in case the insurance didn't pay. We all have experienced, insurance and the the hurdles you go through of getting those payments. So we have the FEMA public assistance, and going through the FEMA public assistance process, it allows you to also look at mitigative or resiliency efforts that you can build in so that you don't have to compete for those funds through the normal hazard mitigation process or the new BRIC program, which we're going to talk about at the end of our discussion today. But it allows you to build it into the project so you get that money now and you're not competing for it. Of course, it's got to be reasonable. It's got to be, it's got to be efficient. So all of that has to be considered. One final piece, we're working with FEMA, we're working with insurance, and we're not sure what's going to happen. So as a backstop, we also built in and secured funding, disaster recovery funds from the Golden Leaf Foundation in order to pay for anything that either FEMA or the insurance doesn't pay for with regard to the mitigation efforts themselves. So this is about a $10 million effort all told, from doing just the normal repairs to doing the mitigation resiliency improvements that we're also building into the project. This is just a quick picture of what's going on at the site right now. Construction is underway. What you're seeing right here, that first picture that I showed you was taken in between these two reactors right here. So all of this was underwater, and this is where the electrical building, and this will be the generator pad. So you can see with the conduit going in how far we're going to be raising these particular assets at this facility. Again, it's going to give them some protection into the future. I will say another thing, resiliency doesn't always mean a brick and mortar project, a capital project. What also came out of this is because they lost all of those motor controllers, they had to operate this plant basically manually for quite a period of time. So operators that had come to rely on SCADA and to do all their thinking for them of when to flip a switch to turn on some pumps, they then had to learn more about the process of this particular plant so that they knew, okay, when this is happening, we need to turn this pump on, and then we need to turn this pump on. All of those things give them more resiliency if an event happens, and maybe it's not a flood, maybe it's some other event that takes out a portion of the power or their SCADA system. But they can now operate this plant manually and do so without having any violations of their permit. So that's, again, another way when we're talking about resiliency, where you can, it's a lot of times it's training that builds that resiliency as well. So let's continue our little tour along North Carolina. We're going to go to Bladen County, North Carolina, in Elizabethtown. So Elizabethtown was impacted by both Matthew and Florence, with Florence probably being the worst of the two. And they are not unlike a lot of small towns across the country. They have a town-owned cemetery. So the town owns this piece of property. Families have bought family burial plots. Loved ones are buried there, and the town maintains that cemetery for those families. So after Matthew happened, there is a road that runs through this particular cemetery, and that road was compromised. And so looking at it, that was the only thing that you could see, was a crack basically in the road. So the thought was the town looked at it and said, it looks like it was just a compromise of a roadbed underneath it. FEMA public assistance dollars came in. They did a repair on the road, put new asphalt, put a new curb on, did all of those things and fixed it back up. Thought everything was great. We're rocking along. 2 years later, Florence comes to town. And Elizabethtown was unique. Again, I mentioned that when Florence came ashore, it stalled out. So Elizabethtown was kind of like the epicenter of the rainfall for this particular weather event. They got nearly 36 inches of rain. Imagine that happening in any community. You're going to have major impacts as a result of that. So while they didn't take a direct hit from the hurricane, they sure did get a big punch from it. And after Florence left, they went and they started inspecting the town, and they went to the cemetery. The cemetery itself was not flooded, but this is what they found. When I saw it, I was like, was there an earthquake associated with this? I mean, it looks like an earthquake happened. Um, so we were like, oh, something major is going on here. And putting the pieces together with the road having been impacted from Matthew, we're like, there's something going on underneath this particular site. So in an effort to help the town and put together a package for FEMA, for the public assistance, to figure out what they needed to do to fix this and return it to its pre-storm condition, we first had to know why this happened. So historical records revealed that this is not uncommon. This was town-owned property, and it was used for fill material, most likely when they were building some of the roads and things like that. This was fill material was put here, and it was probably not ever thought that it was going to be much else was going to be done with it, so it was not suitable to really do a whole lot with, and it wasn't compacted, it wasn't natural material. Well, bring in, before Florence hit, we had a really wet summer. So the groundwater table in Elizabethtown was high. And then you dump on that 36 inches of rain. And so it was saturated. So what was happening was that fill material was shifting, and what is right here along this, what you're seeing is basically the edge of the Cape Fear River. So the cemetery itself was sloughing off into the Cape Fear River. Now imagine you're the town, imagine you've got families who have loved ones buried here, and you've got families who've bought plots, who intend for their entire family to be buried here. The last thing you want to have happen is someone's loved one to be floating down the Cape Fear River. And so this was a project of particular import to the town of Elizabethtown. And we looked at a lot of different options, just like we did with Onwassa. What's the most cost-effective and efficient way to solve the problem, but also to protect this site and to protect this hallowed place for families for the future. We looked at the town looked at buying property and basically disinterring all of the affected graves and reinterring them at the new site. Well, imagine, that was a situation that I don't think anybody really wanted to didn't want to go down that road. So we looked at how we could solve this problem on the site. And I'm going to tell you, it was not an easy battle with FEMA because, FEMA's first choice is to return this to its pre-storm condition. And also the fact that now we tied Matthew to it, and so there was just a lot of hurdles that we had to get through in order to build in the ultimate solution. So this is that road I mentioned. You can see this is the old road and this is the new road that was patched. So that same crack fault showed up again after Florence. So we knew that what happened in Matthew really was the foreshadowing of what we saw after Florence. And the solution we came up with was putting in, I mean, again, it's not necessarily a green solution or anything along those lines, but it's going to protect the cemetery for years to come. And that's installing a sheet pile wall and also putting an under drain system to get the water out of this filled area and protect it from high water tables as well as the high rain events. This is it's under construction right now. This is the sheet pile wall going in, and another little angle on that particular construction right now. This is about a $5 million project. Again, it was an uphill battle to get it funded, but it's completely funded through FEMA as well as the state 25% match that's coming into that. Bids came in great. We should be finished with this project in just a few months. And the good thing is that the families are protected. As a matter of fact, there are burials that are happening while we're doing construction, so we'll have to stop construction while they do perform the burials, and then restart after it's over. But that's all a part of this process. And the cemetery has been here since since the 1800s, since the town was formed. So it's got a lot of history and a lot of family significance for the area. As an aside, just to kind of give you some perspective, Elizabethtown, I mentioned, was also impacted by Matthew. That particular storm event flooded their only EMS facility, and flooded it to the point that FEMA basically said, yeah, you can't use this site anymore for a building, condemn the building. The building's gone, and actually the site is being used by DOT for flood control for roadway. So what we were able to do is cobble together disaster recovery resources, and we built a combined new fire station EMS facility for the town. And the impetus of this was that Elizabethtown was also the staging area for a lot of the rescue teams that were operating in both Matthew and Florence. The Swift Boat rescue teams were located in Elizabethtown, and deployed out from there. So this combined center allows them to have an emergency operation command, and they've got a facility for that in this new center, that people coming in to respond to these types of disaster events, as well as the town and the county to respond to emergency situations, is there. So again, looking at how do we learn from what we've experienced, and not only build things back to the way they were before the event happened, but how do we build in some resiliency and some capacity to allow us to do better and respond quicker next time an event occurs. Continuing our tour down the coast, we're going to go to Caswell Beach, North Carolina. So this particular situation is not necessarily as a result of any one storm event. I mean, it is a coastal island. What you're seeing here is Caswell Beach Road, which is the only way in and out of Caswell Beach. So they were experiencing flooding from moderate rain events, to the point that it made this road impassable. But when they got significant rain events, the road would remain impassable for up to 8 hours. So imagine the public safety implications that happen as a result of that. To get, if you needed to get emergency vehicles on or off or around the island, or people on and off the island, that's a huge deal. So how do you fix that problem on an island, where land is a premium and you don't have a lot of it? So we looked at a number of green nature-based solutions with some areas around the island, and the goal was, how can we get this water off the road as quickly as possible so that we minimize the flooding that happens during these events. And we looked at a number of sites, and one of the sites that we selected, or the site we ended up selecting, was town-owned property, and it's where this boardwalk goes onto the beach. And we looked at working with nature, so a dune infiltration system. So this is the dune area that was selected to be used, but again, because the town owned it, and it was near enough to some other points, because we have to actually pump that water off the road into the dune system. So there were other factors that made this particular site the ideal location. The town owned it. They could incorporate along this boardwalk some educational features that allow people to learn about what's going on in the dune system. But it also gave another layer of benefit. So flood control was the primary issue of concern, but we all know that after significant storm events, a lot of times we end up with beach closures as a result of high fecal counts that are in the waters directly along shore. So this gives us a way to use Mother Nature and the way she normally works things to clean up that water before it gets into the ocean. So it was a multi-layer benefit. So this is the actual dune infiltration system going in. So again, we're using the dune. We're putting an infiltration gallery of pipes, if you will, underneath that dune system, and then it's going to be returned. It's going to look and feel and act just like the original dune that was there, but it's going to have some capability and some capacity. A lot of modeling went into this. A lot of permitting, of course, went into this. But we think this is going to be a really effective solution for Caswell Beach. This shows a cross section of one of the infiltration pipes that's there. And again, the end result of this is going to be that dune is going to look like it did before we started the process. And it's going to function and provide another layer of benefits for Caswell Beach. This was about a $500,000 project, all said and done, and it was funded through DOT as well as local funds. But I think it's going to have a significant impact for this positive impact for this particular community, and a solution that can be replicated in other areas along the coast. So continuing our tour, we're going to make a little stop on the border of North and South Carolina, in Columbus County, a little town called Fair Bluff. And Fair Bluff story is reminiscent of a lot of small towns along our coast and in our area. You know, it's challenged. It was challenged already because of declining populations, loss of industry, all of those things that impact the overall town's resilience, if you will. And then enter in Hurricane Matthew and Hurricane Florence. Fair Bluff sits along the Lumber River, and this, what you're seeing here, is Main Street of Fair Bluff. It became the Lumber River in both Matthew and Florence. So prior to this happening, we were working with this small town, trying to help them do some things with their infrastructure systems, and they were under the gun from the Division of NCDEQ, environmental quality, to do some things at their pump stations. They used to have a wastewater treatment plant, but now they're part of a regional system. So the plant's not there anymore, but they have 6 pump stations for this small town, many of them very, very, very old, 60, 70 years old. They don't make the pumps anymore. A lot of those sorts of issues that you see in small rural communities across North and South Carolina, Georgia, wherever you go. So we had actually worked with them to devise a project to make some minor repairs to all of their wastewater pump stations when Hurricane Matthew hit, and their stations were flooded. They weren't flooded to the point that they couldn't operate, but they did have some impacts. So we used that to make lemonade out of a whole bunch of lemons that hit this town. So this is their main pump station. And it was already a submersible station, a triplex station. It was done when they got rid of their wastewater plant and went to the regional system. What I wanted to point out here is that when the flood occurred, there's actually, I think, drone footage from Fair Bluff was used on like an intro to NBC Nightly News, and it was a flyover. And what you could see, if you knew the town, you could see the top of this pump station. You could see the top of the fence, but you couldn't see anything else. So if you didn't know that was a pump station, you wouldn't know it was there. And that's how bad the flooding was. So what we were able to do, we looked at how do we protect this. Again, it's a submersible station, so the pumps and everything were fine. It was all these other components that were above ground that took a hit. So this is one of the old stations as well. And what I wanted to show here, most of their stations were in little brick buildings, and and this is the water line, the water lines from Matthew and then again in Florence. So these stations were flooded. The pumps were underwater. It came really, really close to getting into the conduit for the electrical and getting the electrical components. So what we did is we said, okay, we've got to do some work on these stations anyway. So how can we make these more resilient for the town, plus also make them, you know, as far as operational issues go, make them more efficient to operate. So we were able to cobble together funding again through Division of Water Infrastructure disaster recovery, as well as Golden Leaf disaster recovery, in order to take all of these stations and that were above ground and the old stations and convert them to submersible stations with floodproof hatches, elevated control panels. They all now have the same generator plugs. We were able to purchase more portable generators at the main site. We were able to elevate the control panels and do a lot of work for about $1.3 million that's going to carry this little community into the future. So this is that same station that I just showed you that was on the inside. It was a brick building. This is what it looks like now with the submersible station with the elevated control panels. So they've got new infrastructure, critical infrastructure components that have resiliency built into them. So we've solved their compliance problem that they were having even before Matthew and Florence hit, and then built in resilience as a result of what we saw with both Matthew and Florence. This is the main pump station where we elevated the generator and elevated the control panels as well. So building in that capacity to help them navigate into the future. Some other exciting things that are going on in this community. They also had a well that was flooded. They only had 2 wells, and one of them was flooded during Matthew to the point that it could not be cleaned. They super chlorinated it and never could get good bacteriological samples as a result of that. So the state said, you're either going to have to treat it like it's groundwater under the influence of surface water to continue to use it, or you can't use it anymore. So we're actually doing a new well. It's at a different site further out, so it's out of the flood zone area of this that we've seen with the flooding associated with Matthew and Florence. So it's going to take some water line to get it back into the system, but they're going to get a new well as a result of this. That's about a $1.5 million project. But even more exciting is, they say the definition of insanity is doing the same thing over and over and expecting a different result. So Matthew flooded their downtown area, like I showed you at the beginning, and then Florence did the exact same thing, just as those businesses were starting to recover. So rather than trying to continue to rebuild that downtown business district, EDA and the state have put in funding, and they're actually going to relocate the business district for this small community and get those businesses back up and running again. So all of this is, resilience doesn't always just factor around your infrastructure systems. It factors around your whole community. So being able to take the lifeblood, those businesses of the community that was already struggling, and move those to an area where they don't have to worry about this most likely threat, which is the Lumber River flooding, and so they can grow and they can thrive, is going to be a real shot in the arm for this community that was struggling. As a result of all this work, just in the past few months, 2 industries have announced that they're going to be locating in Fair Bluff in some industrial spaces that were vacated by industries that left after the Matthew or Florence or before. Low-income housing was destroyed with Hurricane Matthew. That has now been replaced. So the goal is that this community can regain some of its vitality and resilience and and continue on into the future. It's a great story. It's one that I think offers a lot of hope for small town America, particularly small town North and South Carolina, in that you can do some things that make you more resilient from an economical standpoint as well as an infrastructure standpoint. So continuing on, we're going to cross into the border of South Carolina. We're going to go to Little River. So again, this particular area is used to dealing with storm events, hurricanes, and that sort of thing. But Little River Water and Sewer had not necessarily been impacted by one of the recent events, although they were in the declared disaster area. So they used that opportunity to secure hazard mitigation dollars that open up once you declare a disaster. They open up following the emergency situation. So they looked at two of their major pump stations, and kind of ironically, the situation that caused them to look at these two particular stations was an ice storm that happened along the coast. So it wasn't a hurricane. It was an ice storm that knocked out power to the area and crippled the area for several days. So imagine you've got two pump stations that are the main part of getting wastewater collected and to the treatment facility, and those go down, and you don't have backup generators, or your backup generators you have to get there. They're portable, so someone has to get them there, and the roads are iced over, so you've got your staff has to take their life into their hands trying to get the stations back up and running with portable generation capacity. So knowing this, when the multi-jurisdictional hazard mitigation plan was done, Little River participated in that, and they built in permanent backup generation to these facilities. So we were able to use that because that's one of the check boxes to get that hazard mitigation money, is it's got to be in that hazard mitigation plan, in an approved hazard mitigation plan, and secure funding for them to do this backup power generation at these two facilities. Not an expensive proposition. It was about a $350,000 project, with 75% being paid by FEMA and the 25% coming from local funds. But this is one of the sites that had one of the portable generators, and this is the new permanent generator that's built on there. We also elevated, you can see how we elevated some of the control panels as well, building in further capacity, not only for power outages, but also potential flooding in this area. So a number of things that we did that build in capacity and allow them to continue to operate their critical components of their system in an emergency event. Going further south, we're going to go to the barrier island of Sullivan's Island, South Carolina. Like some of the ones we just talked about, Sullivan's Island did not have a direct impact from one of the recent storm events. As a matter of fact, South Carolina has been pretty lucky in the recent past with these storms that look like they're going to take a direct hit on South Carolina, and they go just above the state line there into North Carolina. But there were lessons learned from Hugo, and then there are lessons learned from being an area where the king tides and just natural flooding is occurring at a greater level on our coastal communities. So Sullivan's Island is a barrier island in the Charleston area, and as such, because it's a barrier island, again, a lot of times during these major events, the island is cut off from the mainland. So they've got to be able to operate their critical facilities during those times. They had, kind of like we're talking about in Fair Bluff, but a little bit of a different situation. They had very, very old pump stations. The newest were put in the 60s, so they were that above ground in the brick building sort of thing. And they were spending a lot of money operating those because those old pumps are really, really expensive to operate. And they started looking at how can we better prepare ourselves for these events that could knock out power, and we want to be able to get back up and running as quickly as possible. So the pump stations were a natural fit for this. And as a matter of fact, when we were beginning this project, it was picked up not only by the local news, and that's what you're seeing there on the screen, but also by FEMA. And FEMA used this particular project as a showcase for how a community that maybe hasn't been impacted yet but knows it could be impacted, how they can build resilience into a normal improvement project. They were going to be doing some work on their pump stations anyway, so why not build resilience into that while you're going through it? So these, like we did in Fair Bluff, these are being converted to submersible stations with permanent generation capacity, and elevated controls, all of that fun stuff, flood-proof hatches. This is a picture of one of the old stations. Again, like I said, brick building. But what I wanted you to recognize here is unlike Fair Bluff, Sullivan's Island is a pretty affluent beach community, and so you've got a lot of million-dollar homes and properties in this area, and these facilities sit right on top of each other. So what you're seeing here is actually someone's house that is pretty darn close to this particular pump station. So with that came other challenges of communicating and helping Sullivan's Island communicate to its residents what was about to happen. As you know, when things are there and they've been there for a long time, you don't see them anymore. But you change it up, and all of a sudden, it becomes a bigger issue with regard to sight lines, because what's back here is the waterway and the views that a lot of people pay millions of dollars for. So they're like, are you going to obstruct my view? Are you going to do something to compromise my view? So we did renderings to help Sullivan's Island talk to their citizens about what was going to happen, and the plan for decorative fencing, as well as returning some of the vegetation, and putting vegetation in to limit the amount that you see as a result of this. But this just gave folks perspective of what they would be able to see from the ground level as well as the elevated level. So this is the station that with the submersible pumps, and then everything that's above ground are those control panels and the generators that we're trying to protect from flood events. So again, the idea is good, but sometimes even when you're doing things that are really, really good for the community, you have to do a lot of work in educating the community and helping them to understand that what you're doing is going to put them in a better position than they're in right now with the facilities that are there. So this is work at that same station, Station 3, where we're at putting in, the generator is up, and the platform for the control panels are going in, the submersible stations going in. And this is just a picture of that generator that's elevated. And again, you can see that marsh area, and the this is the bridge back here in the background that you're seeing that comes onto the island. So what we're trying to do is minimize folks' impact to what they're, that may impact their ability to enjoy their property, but also help them to understand that how doing this helps protect their property and protect their property value. So a lot of times when you're helping communities build in resilience, you also need to help those utilities and the units of government convey the message of why you're doing what you're doing and how that's going to better the community as a whole going forward. So all of this is about funding. If there were enough money in the world, we would all be doing this, and we would have been doing it probably a lot quicker than when we have. And a lot of times it takes events, black swan events or catastrophic events or things that we did not see coming, to get us to think about things in a different way. So I don't know if you've noticed this, but in all of the funding that's happening right now, even before what's going on currently, so with the previous administration, you started to see a thread, a common thread occurring through funding legislation. And that was tied to this word right here, resilience. Um, it's all about how do we do things that enable us to recover quicker, better, faster, with less money. I mean, that really is what it comes down to. So you're going to see that. And that brings a lot of opportunity because resilience is a focus. What we're starting to see is that some of our existing programs, like the SRF programs, with the legislation, the reauthorization for these funding bills, they actually built in resilience in there as a priority. So what does that mean going forward? That means that the states, when they take this money, EPA gives them kind of the roadmap. They don't tell them exactly how they do it. They give them the roadmap of how to do it, and they say these are the kind of things we think you should prioritize on how to spend this money, because it's a limited pot of money, and we want to make it go as far as we can and do as much good as we can. So resilience is one of those things, and in North Carolina, that's already happening at DWI. You're seeing a prioritization for projects that have resilient components in them. So great news there. But even bigger is what happened at FEMA. Last year, so this actually has been in place for a number of years. The inaugural year of BRIC, which is the Building Resilient Infrastructure and Communities program, was started last year. So in September, they opened up the portal to accept applications for this new program. And it came about because they started doing a forensic analysis, if you will, of where FEMA's money was being spent. And something along the lines, I believe it was like well over 90%, like 98% of FEMA dollars were spent on post-disaster recovery. So that's significant. It was the events kind of starting with Katrina, but really kind of getting into high gear with Sandy, Superstorm Sandy, really brought this into focus. And they said, look, we are spending a lot of money helping communities recover from these disaster events that are occurring more frequent, and they're getting bigger. So there's not enough money in the world to continue to do this. It's going to be a big deal. So how can we flip the script and try to do this stuff and spend this money before these events occur? If you know anything about how the hazard mitigation program, it was not well funded, and it was funded dependent on annual appropriations from Congress. So there was not a lot of reliability built into this, and it was small grants usually. So BRIC basically transforms how they're doing hazard mitigation and is putting a focus, that all hazards approach that you see in the risk and resiliency assessment, and putting it into a dedicated pot of money that is going to be used for an annual program. So the way it's funded, it's not funded through appropriations anymore, but what FEMA does is they take 6% of federal post-disaster grant funding, of that estimate that they do like 90 days after an event occurs, and they take it, they're not taking it out of the disaster recovery fund, but they're setting aside in their budget 6% of what that number is, to kind of feed that piggy bank and keep it going. Last year, BRIC had $500 million available for these projects. The number of applications far exceeded that amount. So what is happening right now is President Biden has put more money into this, and FEMA is setting aside more money. So there's going to be $1 billion in BRIC funding available for this coming fiscal year, federal fiscal year, to give more opportunities to more communities to make these investments in resilient projects and mitigation projects. Also, we're all learning more and more about the American Rescue Plan Act, and in that there was the Coronavirus Local Fiscal Recovery Fund. That is the first time in our history as a country that every state, every county, every city, every town is getting a direct, non-competitive grant from the federal government. And when the law was written, it was written based on the CARES Act of 2020, but they expanded it. So now they specifically put in there that eligible use of these funds can be used for infrastructure, water, sewer, stormwater, and broadband. And that is amazing, because what that does, and they basically say the only provision for that eligible use is that it's otherwise fundable under the SRF programs, which is wide open. Any stormwater project is eligible. It's not prioritized, but it's eligible. So this gives communities another resource where they may have a project that is important to them but doesn't compete well with some of these competitive grant programs, and allows them to use some of these resources that we've never seen before to make these type of resilient improvements in their infrastructure systems. Finally, a nod to what's going on in North Carolina. North Carolina is doing a phenomenal job at really tackling this problem holistically with the statewide climate risk assessment and resilience plan. Coming out of that is this North Carolina Resilient Coastal Communities program with an initial funding opportunity to do some planning efforts in coastal communities that's funded through some of these niche programs that you can also access to do resilient projects like NIFWIF, Sea Grant, Nature Conservancy. All of those programs are really putting their money where their mouth is with regard to how do we protect our coastal communities and make them more resilient. I mean, everybody loves the coast. We're both North and South Carolina are experiencing growth in coastal communities because it's where people want to live there. And why do they want to live there? It's all of those aspects that we now need to protect and keep them there, that allow our coastal systems to function like they're supposed to. So there's a lot going on. This doesn't even touch on the big daddy infrastructure bill that's being debated right now in Congress. We do anticipate that there will be something coming out of that, but I guarantee you, because I've seen the draft language, that this green infrastructure resilient thread is there as well. So it's going to continue. This is going to be a focus not only from the federal government, but passed down to the states for funding programs and opportunities for you guys to look at projects as you're doing things, as you do your water system risk and resiliency assessment. I guarantee you some things were identified in those, and you can use that as a springboard to identify projects. Let's say you've got to do an improvement project at your water plant already. What things can you do and build in some resiliency in doing that as well? So looking at it from that angle and building those elements in that then allow you to compete for those priority points that give you kind of a leg up for some of these competitive funding programs is all a part of the process. And that same format that is required, by law for the water systems, you can employ those, even though you don't have to do it for stormwater, you don't have to do it for wastewater. That same thought process gets you into looking at how your utility operates from a different angle and allows you to identify those critical elements so that you can then focus on those as you are identifying capital projects going forward and what things you can build in to add resilience. Resilience is not about protecting and not being impacted by every potential threat that is out there. That's not the name of the game. Resiliency is all about how quickly can you recover with the least amount of damage. So you're not going to protect, our utility structures aren't going to be in a little, suit that protects them from everything that could potentially happen. They're not going to be in a suit of armor because things are going to happen, and things you didn't expect to happen are going to happen. But if you think about it and you get this way of thinking ingrained into how you operate and how you look at projects, you're going to be better prepared for anything that comes your way, and you can recover quickly from those events. So with that, I will open it up to any questions that you guys may have.
All right, great. Thank you so much, Angie. The first question, were small scale berming or containment walls considered during design in lieu of elevating structures?
Yeah, so that was, I'm assuming that's the Northwest. It was, and the issue there is in order for it to do what it needed to do, it was going to be a significant berm. So it was not a small berm, but we did look at some of those elements. As it turned out from a BCA, the benefit cost analysis, what we ended up with was more cost effective than some of those other considerations. And it was also, from an operational standpoint, a little bit easier for Onwasa to deal with from a day-to-day operation. Because remember, anything you put into place, they have to operate around whenever they're not under an emergency event. So that all has to be considered as well. But yeah, there was a pretty detailed process where we looked at a number of options.
Okay. Next question. Were generator noise concerns raised by the Sullivan's Island residents?
Sure. That was not, some of these stations did have generators on them as well, but I think that any concern that came about as a result of those noise issues was mitigated to the point that the only times those generators would be in operation would be under emergency situations, where most of these homes probably have their own generators that kick on if the power is out. So that was, again, when you frame it into the conditions that a lot of this is going to be operated in, where we're dealing with an emergency, that kind of ameliorates some of that concern. But there were a lot of concerns. I'm telling you, it was probably more of a community outreach than we anticipated. So.
Okay, it looks like that's all of the questions. Angie, thank you so much for your time today. We really appreciate it. Everyone, you have a 15-minute break, and then sign back on at 10:15 for our next session. I will see you all soon. Thanks again,
Thank
Angie.
y'all.